On number 2, we're still simplifying the expression, but now we have some parentheses that are in part of our problem. Parentheses are only necessary if there's something outside to be done to the numbers inside the parentheses. So if there's a number in front, for instance, then you have to distribute it to get rid of the parentheses. Or if there's an exponent outside the parentheses, then that reminds you to multiply that by itself that many times. But since there's nothing outside either one of these parentheses, then they're not necessary at all. What's in front of this parentheses is a 1, and distributing a 1 is not going to change the terms inside that second parentheses. So this problem is exactly the same as if I rewrote it without the parentheses at all. No change whatsoever. So I'm still looking for like terms again. So remember, I can only add x squares with other x squares. There's not any other x squares in the problem, so that 3x squared is just going to be in my answer. My next term is a negative 6x. It can only be added to other x's. Here's a positive 5x right here. When I add those, remember, I'm still going to have an x. It's just how many x's do I have? Well, I had negative 6, and I added 5. Negative 6 plus 5 is negative 1. Just like in number 1, you can put negative 1, or you can just have the subtraction sign in front of x. They mean exactly the same thing. Negative 1x and negative x are the same. The next term in my polynomial here is the constant negative 2, and I can add that to another constant of positive 3. Negative 2 plus 3 is positive 1, so I have to put the plus 1 at the end. Don't forget your answer should be in standard form, which mine is, because the exponent on x goes from being 2 to an understood 1 to not having an x. So that is called standard form, and either one of these answers is acceptable.